Good afternoon, everyone. Am I audible? Say yes or no. Hello, JNV Ahmedabad. Am I audible? Okay, very good, JNV. So today, Akshmala madam is actually busy in some stuff, so I am taking your class. Uh, we'll start in few minutes, 2 or 3 minutes. After that, we will start. We will wait for some time for few more colleges, few more schools to join. Till then, you can revise your concepts, your previous topics. Can you tell me the last topic that were discussed in the class, in the last class? The last topic, I think capacitor is discussed now in the last class. Combination capacitance, okay, and numerical. Done. So today we are going to discuss about dielectrics. That what is the effect of dielectric on the capacitance, on other factors like on charge, on energy, and the grouping of capacitors inside, grouping of dielectric inside a capacitor, like these things. So can you tell me the exact formula for the, I will say, uh, capacitance of a general system? What is the general formula of the capacitance? Can anyone tell me from JNV Ahmedabad? Okay, if I see the name JNV Ahmedabad, is it a group of students studying, or simply one or two students are there sitting behind the screen? Okay, so two students are sitting. Okay, why the number is so less? Achal Bihun. Okay, welcome Achal. All students are coming. Okay, so I think I started the class little bit earlier the time. Okay, so keep your camera on so that I can see all of you, and try to open your notebook and bring your pen with yourself so that you can solve the questions with me as well. Is there anyone who attended the class of 11th enable, and someone is there who can identify, who can recognize me, who can identify me, that yes sir, I know you? So I will start the class now. I think most of the students have come. Okay, so first of all, we will start with the some recall test. There is a very fundamental basic question. You need to answer that question by yourself. So let's start. These are the topics that we are going to discuss in today's class. Okay. So this is your first question. This is a recall test. The things that you have studied earlier, you need to solve based on that. And I will give you some 1.5 minute, or you can say 1 minute and 30 seconds for this question. Try to solve it out. Okay, just confirm one thing. Is my screen visible to everyone? Is the question visible to everyone? Just confirm once. Okay, it's visible. So try to solve it out. You have 1.5 minutes. Are you solving? Someone is saying JNV Ahmedabad is saying option number D. Okay, let's check it further. Anyone else? JNV Rajkot? Okay. So question says, first of all, let's start. There are two metal plates. Something like that. One has a charge Q1, another has a charge Q2. Clear? Now, when these two plates are put together or brought close together to form a parallel plate capacitor, this is a parallel plate capacitor of capacitance C something. The potential difference between them is, so the potential difference, if I say, everybody knows that, and everybody will say, yes, sir, we know that delta V is equals to Q by C that you have studied till now. But what is the most important thing here to learn, to remember is when you talk about this Q, this charge Q is nothing but the charge on the inner surface of the plates. What is the inner surface? The surfaces which are facing to each other are known as inner surfaces. Like this is outer surface. This is also outer surface. And these two surfaces are inner surface. So what is the exact situation is the delta V is equals to charge on the inner face of the capacitor divided by C. This is the potential difference. I think everybody remembers the relation. Now my task is to calculate this Q inner surface. Task is clear. Now do one thing. What if I say that when you place one or more than one plates together, then the charge on each of the surface can be calculated very easily. I am telling you the trick here. What you need to do, first of all, there are four surfaces, 1, 2, 3, and 4. We can calculate charge on each surface. What is the process? First of all, add the total charge of the system. So total charge of the system is Q1 plus Q2. Is it clear? No doubt in that. And divide it in half and share it to the outer surfaces of the system. If there are three plates, then outer surfaces will be first and the third plate, third capacitor, third plate. So divide it in half. That is Q1 plus Q2 by 2. Q1 plus Q2 by 2. These are the charges on the first and the last surface of the system. Now two surfaces are remaining. If you see that, again, on the first plate, there is Q1 charge in total. This Q1 charge in total. And on the left surface, charge is q1 plus q2 by 2. So remaining charge will be on the second surface. So second surface charge will be q1 minus q1 plus q2 by 2. This is going to be the charge on the second surface. You can simplify it. It will become q1 minus q2 by 2. This is the charge on the inner surface, and you can write it here, q1 minus q2 by 2. One more punchline here that you can remember is, in any system of plates, conducting plates, the charge on the facing surfaces or opposite surfaces is same but opposite sign. I'm repeating my words. In a system of plates, the faces which are towards each other, or the surfaces which are facing to each other, have equal and opposite charges. So this surface will have negative of q1 minus q2 by 2 charge. So we know the charge on the inner surface. So net potential will be, you can write it here, delta V will be q on the inner surface is q1 minus q2 by 2, and this C is there. So this is your answer, which is option number D. Very good, Ahmedabad, JN Ahmedabad, very good. You clicked it right. Is there any sort of doubt to anyone in this particular question? JNV Gandhinagar, Jamnagar. Okay. Any doubt to anyone? Should I move further? So what you have learned from this golden relation you have cleared your concept that charge on the inner surface is required for the calculation of capacitance or potential, whatever you want to calculate in a capacitor, and how to calculate the charge on the surface in a system of plates. If there were 3 plates, I will give the same question to you in a homework. Like, this is the question that we have done on recall test. Now there is a simple question I am giving you. There are 3 plates, 1, 2, and 3. Done. Like this is 2q, 5q, minus q. Done. You need to find the charge on each of the surfaces. I am mentioning the surface 1, 2, 3, 4, 5, 6. So first of all, just tell me charge on the first surface. Charge on the first surface, anyone can answer quickly within 10 seconds. Charge on the first surface. What will be the charge on the first surface? Be quick. It's a simple mathematics. Am I audible? Stay connected. Say yes or no. Anyone? At least say yes or no so that I can identify. Yes, sir. Okay, so what will be the charge on the first surface? What will be the charge on the first surface? Okay, I'm telling you. Again, I am clearing the concept here. Listen. What you need to do, first of all, add the charges of the system. The system has 3 plates, 1, 2, and 3 plates. And the total charge of the system is, if you can see that 2q, 5q, and minus q, that will be 6q. So total charge of the system is 6q. Done. And the charge on the outer surface will be half of this. So half of this will be 3q and 3q. Is it clear? Is it done now? So charge on the outer surface will be 3q and 3q. First step is done. Second step is very simple. Listen to me very carefully now. The charge originally on first plate is 2q. But on the left surface, it is 3q. So how much charge will be on the second surface? So original charge is 2q minus left face has 3q charge. So this face will have minus q charge. If second face has minus q, then third face will have plus q because all the surfaces will that are facing to each other will have equal and opposite charges. Mark my words. This is just the revision thing. Now, can anyone tell me the charge on the fourth surface? Original charge on this plate is 5q. You have 5q total charge. You have 10 rupees in total, or you have 5 rupees in total. In your left hand, you have 1 rupee. How much rupee will you have in your which hand? Right hand. How much money will you have in your right hand? You have total 5 rupees. In your left hand, you have 1 rupee. In your right hand, you will have 4 rupees. That's a simple calculation. That's 4q. That will be minus 4q. Equal and opposite. Can you check that? Is it clear to everyone? This is important question. Very much important. Now moving further towards the dielectric section. No one is responding. This is really not good. How will I come to know that you are getting the things? JNV Rajkot, yes, sir. Okay. So is the concept clear to everyone? Now, if I talk about what is dielectric, in simple words, I can say, okay, Ahmedabad is saying yes, sir. Dielectric is nothing but insulating materials. Dielectric is nothing but insulating materials. Now, very simple. Now you can further classify those in two factors, that is polar and another is non-polar. Done. Now, remember with me or try to figure it out. Polar dielectrics are made with molecules which have some permanent dipole moment. Repeating my words. They have, I am writing in short, permanent dipole moment. And non-polar, they don't have permanent dipole moment. So I think you have studied that in your classroom in a lot of details. So I'm just showing the representation. Polar dielectrics can be represented, the molecules of polar dielectric can be represented in such a way like this one. They have some dipole moment plus and minus. Like the charge has some separation, positive and negative charge has some separation. And non-polar can be represented by a simple circular shape. Done. Now these are the dielectric, simple thing of dielectric. The basic idea of dielectric, these are insulating materials. They do not allow the flow of charge. They can be polar, they can be non-polar. Polar have permanent dipole moment, non-polar have no permanent dipole moment. Clear, moving further. Effect of external field on dielectric. Listen very carefully. Let's suppose you have a dielectric. You have studied it in your classroom. Say yes if you have studied it in your classroom. Now, let's suppose this dielectric has a dielectric constant K, or this is a dielectric. Simply, I am writing it a dielectric. Now, this dielectric is placed in an external field. This is the some external field E naught. So what will happen due to this field? Some charges gets polarized and new electric field is created inside the dielectric. Try to mark my words. A new electric field is created. Let's suppose this field is E, induced. For induced or E polarized, I can write it as E polarized. So net field inside the dielectric is what? Net field inside the dielectric is E naught minus EP. Is it clear? Original field was E naught. A new field is created inside the dielectric, which is EP, P for polarization. So net field is E naught minus EP. So what I can conclude here, when a dielectric is placed in an external field, the value of field decreases. Okay, so conclusion is the field inside the dielectric will be less than the original external field. Will be less than the original external field. So one punchline that you can remember here, when you place the dielectric in an external field, the field inside the dielectric is less than the external field. Clear? Now new word is coming, dielectric constant. What is dielectric constant? It is denoted by K. K is what? Original external field divided by reduced value of field. You can remember E naught is the external field, E is the reduced value of field. So the ratio of these two is called dielectric constant. This is a unitless quantity. This is a unitless quantity. Good afternoon, JNB Bhavnagar. Very good afternoon. So dielectric constant is unitless quantity. Now tell me one more thing. For a insulating material or for a dielectric, what is true? Is K greater than 1 or K less than 1? Which is true? Out of these two options, like suppose this is option A, this is option B, which option is going to be correct? Be quick in your responses. I am repeating my words. Be quick in your responses. Very good. 2% have responded. Someone, Gandhinagar is saying A, and Ahmedabad is saying B. Rajkot is A. Anyone else? Quick. Okay. So majority of the vote goes to A. Okay. Now listen. This is simple mathematics. Can you see that this is original field? Original field, or you can say original external field. And what is this E? This E is reduced field inside the dielectric. Am I right? Now numerator is larger as compared to denominator. If numerator is larger, like numerator is larger 10 and denominator is 5, then you can say this is going to be 2. Clear? So which option is correct? Option 1 is correct. Done. And now remember one thing, for air, K is approximately equal to 1. For air, we can take dielectric constant as nearly equal to 1, not exactly to 1, but we can take it as 1. So is the concept clear to everyone? What's happening here? So I will move further towards the next section of this class. Now, okay, very good, Gandhinagar. Now there is a situation, the main concept that we are going to discuss that dielectric inside the capacitor. So first condition that we can discuss here, when dielectric is completely filled. Now look at that. Let's suppose this is a capacitor. You know that what is capacitor? This is a parallel plate capacitor. Basically, this is a parallel plate capacitor. Now a dielectric slab is inserted. Before inserting, I will tell you few things here. Can anyone tell me, like this is plus sigma, this is minus sigma? Can anyone tell me what will be the field between the plates? What will be the field between the plates of the capacitor? Okay, someone might be saying that we cannot type sigma here. So you can don't symbolize it. You can write it as SIGMA, sigma rule type of. So E naught is what? Sigma by epsilon naught. I think you should remember, right? Sigma by, okay, I can understand this is not E, this is epsilon naught. Sigma by epsilon. Now what's happening here? I have placed a dielectric slab inside it, which this is the dielectric slab, which completely fills, and it has a dielectric constant K. Now, what will be the value of field? Everyone will say that, sir, field will decrease, and this reduced value of field will be E is equals to E naught by K. How can you calculate it? Because I know that K is what? E naught by E. So E is what? E naught by K. I can easily calculate it. E naught by K. Now, the capacitance C is equals to A epsilon naught by D is the capacitance when it is placed in air. When a dielectric is filled, comes times. It becomes K times. So first thing you should remember, and I think everybody knows that because our main task is to discuss the question. So I will write it here. C is equals to K times C air. Can you understand this statement? Capacitance becomes K times of air. When there is air between the plates, then capacitance is A epsilon naught by D. When the dielectric is filled, it becomes K times. Now moving further. Dielectric is partially filled. Now this is again an important situation. Is there anyone who remembers this formula or have studied in the classroom? Like this is the parallel plate capacitor. Separation is D. Sigma and minus sigma. Now a dielectric slab is inserted between the plates like this, which has a dielectric constant K, and thickness of this plate is T. Done, I think. Clear now? Now listen to me very carefully. In this situation, the capacitance C is equals to A epsilon naught divided by D minus T plus T by K. This is the golden relation for partial filling of the dielectric. Is the statement, is the formula clear? You can write the formula on your notebook because we are going to use this relation. Now listen to me. I am doing something different here. Listen very carefully, listen. Now be alert. Be alert, we are going to discuss something special here. can you identify that this portion, the empty portion, has air? Is it clear to everyone? The empty portion has air, clear, and dielectric portion has dielectric constant K. Now, can you see that air has a thickness like dielectric has a thickness of what? Everyone will say dielectric has a thickness of T. Then what is the thickness of air? What is the thickness of air in this diagram? What is the thickness of air? Total thickness of air. Can anyone tell me? Acha, be quick. D minus T. Very good, Gandhinagar. JNV Gandhinagar. Okay. So D minus T. I think clear na? Total separation is D, dielectric is T, so remaining is D minus T. So can you see that formula C is equals to A epsilon naught? That is very common thing, A epsilon naught. Very good. T is the dielectric thickness divided by its constant. This term is D minus T is the thickness of air divided by its constant, and dielectric constant of air is what? I told you it is 1. So can you see that when now I can you break the formula out? Can you break this formula out? D minus T is nothing but the thickness of air. Now what variation I can put here? Like suppose on the next slide I will say, suppose there are combination of dielectric, I will say. Combination of dielectric, I will say, let's suppose this is a capacitor and two dielectrics are filled here. Something like that. This is for thickness T1, this is for thickness T2, and this dielectric has a constant K1, and this dielectric has a constant K2. This is plate plus sigma, this is plate minus sigma. So multiple dielectric, this is the case of multiple dielectrics. What's special here? The dielectrics are placed parallel to the plates. So this dielectric, one dielectric, second, all these dielectrics, you can place 3 dielectrics, all these slabs are placed parallel to the plates of the capacitor. In this situation, I will tell you 2 or 3 things. First punchline here. If we identify this boundary, then this first portion, you can see my cursor, the pen here. This portion has some capacitance C1 and this portion has some capacitance C2. And these 2 capacitors are in series. These 2 capacitors are in series. So it forms series combination. It forms series combination. First main point. Next, if it is a series combination, then equivalent capacitance of this system 1 by C equivalent is equals to 1 by C1 plus 1 by C2. This is the next important thing. Clear? Now, you can write C1 as, can you see that this portion has a capacitance C1 and this is completely filled with dielectric K1. So you can write it as A epsilon naught K1 over separation is T1. Similarly, C2 you can write A epsilon naught K2 over T2. I am assuming that you know the formula of capacitance of a parallel plate capacitor. So it forms 2 capacitors. Now, if 3 slabs are there, it will form 3 capacitors, and capacitance you can write for each. Now you can put these values in the first equation and you will get the answer. So I am not going to put these values. I am telling you the idea behind this multiple. Now, what's special here that you can learn? I am going back to the previous slide. I am redrawing the diagram again. This portion is K1, this portion is K2. Now you will resemble that this is sigma, this is minus sigma. Now, what is the capacitance of this system? And I am writing it right in front of you. C is equals to. Now listen very clearly. First of all, write A epsilon naught. Very good. A epsilon naught I have written. Now, T upon K is thickness of one medium divided by its dielectric constant. So thickness of one medium is T1, another medium is T2. So I am writing T1 by K1 plus D minus T is another medium. D minus T another medium is what? Air. Here another medium is what? K2. And thickness T2 by K2. This is your answer. Are you getting my point? What I'm saying? You can write this formula without using such calculations. You can write directly, but you should know, you should remember this thing. But you can directly apply this one. A epsilon naught is common thing divided by thickness over its constant, thickness of second medium over its constant, plus if there were any other plate, you can write it at T3 over K3 as it is. Very simple. Clear? Is it clear to you? Should I move further? Now, one case we have discussed parallel plates when this is placed parallel. Now, another case is perpendicular to the plates. Very good, Ahmedabad. Now, again, I am saying these are the two parallel plates plus sigma minus sigma. And let's suppose two dielectric plates, something like that. K1 and K2 are inserted. Then these plates you can see that are perpendicular to the original plates of the capacitor. These dielectrics are perpendicular to it. Now you can see this portion that I am highlighting is one capacitor and this dotted portion is another capacitor. It has a capacitance C1, it has a capacitance C2. Clear? Now, can you see that both these capacitors have same potential across its end? If they have same potential, so they are in parallel. So first important thing that you should remember, what it forms parallel combination. Can you read it out? This is written as combination. It forms parallel combination. And for parallel combination, what equivalent capacitance? C equivalent is equals to, everybody knows, C1 plus C2. Now, how will you write C1 and how will you write C2? C1 is what? A epsilon naught over D. A epsilon naught over D. So can you see that area of the plate, this capacitor, area of this capacitor is somewhat decreased. Let's suppose A1, and for this one, let's suppose A2. Let's suppose A2. Separation remains the same for both. Separation remains both same for the both. So you can write C1 and C2. You can put in this equation and you will get the answer. So main idea behind it is clear. I will take one more topic before moving to the questions. And after that, we will do just questions. This is the last topic. This is the most important topic. First of all, read out the heading. Effect of dielectric with and without battery. So till now, what we have learned when dielectric is inserted, capacitance increases. Capacitance increases. And when completely filled, it becomes K times. That's all. Now, try to understand the situation that I am telling you here. Focus. The most important question I am going to discuss here of the JEE exam. Listen. Let's suppose there is a capacitor. Listen to me very carefully, each and every word. This is a capacitor which has a capacitance C. Done. Now this capacitor is charged with a battery. First of all, tell me, are you there? Are you listening, everyone? In alert mode. This capacitor is charged with a battery. 20 JNV schools are there. Everybody is not saying yes, sir. Only Gandhinagar, Gujarat is active, I think. Ashwani, Swankar, JNV, Rajkot. Rajkot is also in Gujarat, now I think. Okay. So Gujarat is very active. Okay, so this capacitor is charged by a battery of potential V. This is the first step. You remember this one? Now, second step. Bhavnagar, Panchmahal. Okay, very good. Everyone is active now. Now, coming back to the topic. Vishakha. Very good, Vishakha. Now, coming back to the topic, after this statement that is charged, another statement came, that is battery is removed. Statement, listen to me, I am telling you the two questions here. Battery is removed and dielectric inserted. Dielectric inserted. Tell me the capacitance, charge, potential, and energy of the capacitor, or you can say new capacitance, new charge, new potential, and new energy of the system. So are you listening my topic, my things? And next is, they will say that battery remains connected. Battery remains connected, but they have inserted dielectric. They have inserted the dielectric. Now they will again ask the same questions. What is the new capacitance, new charge, new potential, and new energy? So one thing I will tell you, that if battery remains connected, try to catch the main word. If battery remains connected, in this situation, the diagram will still look like this, and this is filled with some dielectric K. Dielectric of dielectric constant K. Battery is a device which is used to maintain a constant potential across the device. Which is used to maintain a constant potential across the device. That means until battery remains connected, the potential will not change and new potential will be equals to original potential. Mark my words. I have highlighted the keyword here. We will calculate all other things. Now, what will happen if battery is removed? Then diagram will look like something this one. Dielectric of dielectric constant K, and battery is removed, but the battery is removed after charging. So if battery is removed after charging, it has some charge, like it has some charge Q. The capacitor has stored some charge Q before removing the battery. Now battery is removed. Where this charge will go? Very good, Bhavnagar. If battery is removed, then the original charge, which is Q, it has no escaping. Where it will go, no path. It is isolated. If it is isolated, then charge will remain constant, and you will say that Q dash is equals to Q. Now I am writing all other things here. Capacitance always becomes K times if it is completely filled. Capacitance is K times if it is completely filled, irrespective of what, everything. Now, Q is what? It will also become K times. How you can solve it? Q is equals to C delta V, C dash, V dash. C dash is what? Kc. V is dash is what? V. So Cv is the original charge. K times Cv means K times Q. Energy, U dash is equals to K. Try to remember this table. You can take the screenshot or whatever the process you are following till now. You can do that. Potential will become energy will become U by is this clear now? Move further. Two important things. If battery, what is the highlight? If battery is connected, what will be same? This line you should remember. If battery is removed, which will same? Which quantity will be same? That you will should remember this one. These two quantities should be remembered. Or you can play. Was there any interruption in between? Okay, so we are starting the questions here. This is your first question on your screen, and I will give you 1.5 minutes for this question. Try to solve it out within the specified time limit. And tell me the answer. Can you all turn on your camera so that I can see whether you are solving or not? And in which position you are? Anyone willing to turn on the camera? JNV Shimoga is quite absent. Shubhangi, JNV Buldana, JNV Vizag, Panchmahal, Nanded, Jamnagar. Okay. Vishwa has turned on. JNV Ahmedabad. Are you solving the question now? Okay, very good. Okay, let's see who will win in this race. Okay, someone has answered. Gandhinagar is saying option C. Bhavnagar is saying option A. So let's try. Rajkot is also students here. Okay, very good. Okay, so you have questions solving material. Okay, so let's try to solve this question. What it says, Two capacitors, each of capacitance 40 microfarad, are connected in series like this. These are connected in series, each of 40, 40 and 40. The space between one of the capacitor is filled with dielectric material of constant K. Now one is filled with material dielectric constant K. If I filled this with material of dielectric constant K, so its capacitance will definitely become K times and it will be 40K. Can you see that? Its capacitance will become 40K. Is it clear? Now the question says equivalent capacitance of the system becomes 24. Now C equivalent they are saying is 24 microfarad. Everybody knows that for series combination, C equivalent is C1, C2 divided by C1 plus C2 is equals to 24. Now you have to calculate it. C1 is what? 40. C2 is what? 40K divided by 40 plus 40K is equals to 24. Is it clear now? Can I cancel this 40 with these two 40s? So this is 40K. I'm multiplying it 24K plus 24. Now there might be a confusion in some of you. I can see the faces of some of the students. Is it clear? I can cancel this 40 taking common. So what will be the remaining part? K plus 1. And if K plus 1 is remaining, you can see I am multiplying, cross multiplying it. So it will be 16K is equals to 24. So K is what? 24 by 16. That is 16 ones are 16. 16 fives are. So that is 1.5, which is option number A. And I think Bhavnagar has given the correct answer. Very good. Is the statement clear to you? Question clear to you? This part is clear? Okay, very good. Satyen Singh. Very good. Moving further for the next question. Again, a very good, simple question. All these questions are PYQs. Again, I am giving you some 1.5 minute, 1.5 minute. Try to solve in that time period. Don't turn your camera off, Rajkot. You all were looking sincere. So no need to turn off the camera. Yeah. This is the feel of the classroom, na? Okay. Anyone who got the answer? Bhavnagar is saying option C. Okay, Bhavnagar, recheck it because this is not the right answer. Okay, look at me. First of all, we will draw the diagrams. We will draw the condition that's mentioned. Gandhinagar is saying option D. Okay, let's check now. Let's check now. Don't worry. Have a look. First of all, I will read the question. The parallel combination of two air-filled parallel plate capacitors have capacitance C and NC. Now, there are two capacitors. One has a capacitance C and another has a capacitance NC. Clear? Connected to a battery of voltage V. Now they are in parallel combination. They are connected to a battery of potential V, something like that. This is the first statement. When capacitors are fully charged, the battery is removed. Now again, now can you identify the situation that I have told you in the last topic of the class, last theoretical topic, that capacitor is charged, battery is removed, something you can remember. The battery, I have removed the battery. And after that, a dielectric material of dielectric constant K is placed between the two plates of the first capacitor. First capacitor means first one, this one. So if you put the dielectric inside it, its capacitance will become Kc. Is it clear to everyone? Don't look behind. You can see on the board. Again, you are watching behind. You can see in front. So its capacitance will become Kc, and it has same capacitance Nc. So the new potential difference of the combined system is, so whenever, I think in your previous classes you have studied such kind of question, that when a charged capacitor is attached to an uncharged capacitor, I have seen something like that in your previous classes. So what is the common potential? You must have remembered a formula for common potential. Common potential, let's suppose it is V, and this common potential, let's suppose something different, V naught, we can take it. Common potential is what? Total charge divided by total capacitance of the system. So total charge on this system is what? In this situation, there is no battery. That means system is isolated. So the charge it has gained in this situation will be the total charge of the system. Are you getting my point? What is common potential? Total charge over total capacitance. So what is total charge? Is the charge that the system gains in this first situation when battery was connected. So this charge is, everybody knows that Q is equals to C delta V, that is CV. And this Q2 will be, NC is the capacitance, V is the potential, NCV. So total charge is what? I am writing here, CV plus NCV. This is the total charge of the system. And total capacitance of the system is what? Kc plus Nc. Kc plus Nc. Now again, I can see that C will be taken common and can be cancelled. In the numerator term, V is also common. It will be 1 plus N divided by K plus N. So which option is correct? Can anyone identify which option is correct out of these four? Yes, 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 yes. Option A is correct. So what you should remember, what is common potential? Total charge over total capacitance. This formula you can write in this way, Q1 plus Q2 divided by C1 plus C2 as well. But this formula is valid only when the positive plate of first capacitor is connected to the positive plate of second capacitor. If this is reversed, then there will be a sign of minus. There will be a sign of minus that you must have learned if positive plate of first capacitor is connected to the negative plate of the other capacitor. Now, I will give you the same kind of question. Okay, first of all, let's move further for the another question because time is very less. So we can't give you the similar question again. I will give you some 1 minute for this question. Try to read this question. And I know from after 3 or 4 minutes, your another class will be started. Can you say this is these are the two plates, sigma and minus sigma, can easily identify the plates in the system. And the separation is 3 mm. This separation is 3 mm. Someone has answered option D. JNV Buldana is saying option D, which is 14. Okay, let's check it out. The gap is filled with some materials. This, the electric constant of a material which gives same capacitance when fully inserted. Okay, no problem. Very good, JNV Buldana. We will check the answer. Okay, tell me one thing. Can you see that this is okay? K1, K2, K3. Let's suppose this is K1, this is K2, this is K3. Let's suppose. Can anyone tell me this is capacitor C1, C2, and C3? Can you tell me what is the combination between these three capacitors, whether they are in series or in parallel? Which combination is there between these three capacitors? One dielectric forms one capacitor, another capacitor, another three capacitors are there. What is the combination between these three capacitors? Okay, someone has answered. Okay, Ashwini is also saying D. I am not asking the answer here. I am just asking a very simple question. What is the combination between these three capacitors? Like this is one capacitor I am highlighting you. This is another capacitor, two capacitors, and this is third capacitor. If you connect a battery with this system like this, then very good. JNV Nanded, very good. All these three capacitors are in parallel because all these are connected with the same plates and they will have same potential. So this is a parallel combination. So in this situation, you will write C equivalent as C1 plus C2 plus C3. Clear? Now, if the total area of this plate is A, and they are saying equal thickness, then this area will be A by 3. This is A by 3 and this is A by 3. Are you getting my point? Are you getting my point? What I'm saying, that area of these three capacitors will be A by 3, A by 3, A by 3. Now I am writing C1, C2 and C3. I'm just trying to write C1, C2 and C3. What is C1? You will say capacitance of a parallel plate capacitor is A epsilon naught over D. This is the basic formula, fundamental formula. So C1 is what? Area is A by 3, epsilon naught over D. Separation of each capacitor is D. That is 3 mm something. 3 mm. Okay. Now for C2, area is again A by 3 epsilon naught K2 by D, and for C3 it is again area A by 3 epsilon naught K3 by D. I have written C1, C2 and C3. Now they are saying the dielectric constant of a material which gives same capacitance when fully inserted in above capacitor. Now they are saying what will be the dielectric constant of the material which is fully inserted and give the same capacitance. So that will be A epsilon naught K over D. Now let's suppose the fully inserted dielectric has a constant K, this K. So its capacitance will be area is A, epsilon naught K over D. What are the things that you can cancel? A epsilon naught, A epsilon naught, A epsilon naught, A epsilon can be cancelled. And D is also cancelled. Clear? So what will be K? K is K1 plus K2 plus K3 divided by 3. Now I think question becomes very clear and very easy to solve. Can you put the values K1, K2 and K3? 12, 10, 22, 36 by 3, that is 12. If you put the values, it will be 12, which is option number C. Now listen to me very carefully. This is the last question of the class right now, because the time is over. We have some more questions here. We will discuss in the next class, or the ma'am will discuss in the next class. So what I'm saying in this question, 3 capacitors C1, C2 and C3 are there. They are in parallel, so equivalent will be C1, C2, C3. Add कर देंगे इन दोनों को, तीनों को. Now what it asks, the dielectric constant of a material which gives same capacitance. Now they are saying the between the plates, if I place a full dielectric slab, then what should be its dielectric constant? इसका dielectric constant क्या हो, so that capacitance in both the cases is same. Capacitance in both the cases is same. So that's what I have solved here. I think question is clear. So it's time, I think, to say bye. Hopefully you got everything. If you have any doubt in any of the questions, you can ask. Otherwise, I'm ending the session. Any doubt to anyone? Ahmedabad, Ashwini, Sonkar, Rajkot, Gandhinagar, Nanded. Everything clear? Okay, so where are you getting these notes of the class? Can anyone tell me? Are you getting the notes of the class? Or are you willing to get the notes? No, there is no such desire. Okay, so I am ending the session. Okay, Gandhinagar is saying yes. Ahmedabad is also saying yes. So you are getting me. So tell me where the notes were shared. Is there any specific folder where the notes are shared? No problem. I will share it. Somewhere I will share it. So you will find. So, okay. Bye, everyone.